Hey guys, once again, welcome to our channel. Hopefully, you guys are doing great. In today's segment, we will be dealing with an extension of one of our previous topics that we were discussing, and that, as you can suggest by the video's thumbnail, Introduction to Electron Shells. Now, you might be wondering why we are discussing this concept again. This is because we discussed how we can represent the structure of an atom, and we also discussed that there were two ways that in which we can represent the structure of an atom. We could use either electron shell diagrams, or we could use either electronic configuration. We could write out a special notation called electronic configuration. In our previous video, we just discussed the first part, that was using the electron shell diagrams. And in this video, we'll be discussing the second part, that is writing out the special notation, electronic configuration. So before we just get started off with the topic, let's just have a look at the syllabus. So according to our syllabus, we have already covered isotopes, and we were discussing, and if you see the second statement, let me just 1 second. If you see this part, right, this one, we will be discussing only half of this in this video. All right, so we will be describe the buildup of electrons in shells. All right, the second part, the significance of noble gas, we'll be discussing in the upcoming video. But for now, we'll be discussing only buildup of electrons in shells. So let's just get started. All right, so electronic configuration. So what do you mean by it? But before I just directly jump into the topic, before I get cough, let me just recall that electrons are held in shells, and shells are represented as rings around the nucleus. It is really important to understand that the maximum number of electrons that a single shell can hold can vary, and which we discussed in our previous video. We showed you the shell. All right, we showed you how the structure of an atom looks like. There are rings in which electrons and which are negatively charged electrons are just randomly moving. The nucleus is positively charged, which is at the center. All right, and we also saw that how electrons are arranged. All right, how these shells are arranged. Now, electronic configuration. Now, the arrangement of electrons in shells can also be explained using numbers. There is a clear relationship between the outer shell electrons and how the periodic table is designed. The number of notations in the electronic configuration will show the number of the shells of electrons the atom has, showing the period in which that element is in. Now you might be just confused a bit here, but in the upcoming slide you will be more clear that how we can represent this all. The last notation shows the number of outer electrons the atom has, showing the group that element is in. Elements in the same group have the same number of outer shell electrons. All right. Now, we discussed that, firstly, we discussed that we can represent the arrangement of electrons in shells, and this can be explained using numbers. And there's a clear relationship between the outer shell electrons and how the periodic table is designed. Now, there's something, if you look to your periodic table, you will notice that at the sides of the periodic table and at the top of the periodic table, we have seen some numbers 1, 2, 3, 13, 14, 15. Those are the groups, and on sides we have periods. All right, so they also represented by numbers. The number of notation in the electronic configuration will show the number of shells of electrons the atom has, showing the period in which that element is in. Now this one I will take the support of a diagram. Now here's a diagrammatic snapshot. Now you can see clearly that I have written there is an atom of chlorine, and we have drawn a electron shell diagram, and we also have written a electron special notation called the electronic configuration. So you can see what happens here. In the first shell, okay, let me just take this pointer. All right, in the first shell, if you see this part, all right, you can see there are two electrons present. And we discussed in our previous video that how electrons, what is the order in which electrons are arranged. So we saw that electrons in the first shell can hold up to only two electrons. They can accommodate only up to two electrons. All right. Then in the second shell, it can hold up to 8 electrons. In the third shell, also it can hold up to 8 electrons. If it has more electrons, it will continue with more shells. It can hold up to only 8 electrons, and it goes on. All right. Now, this we have already discussed in our previous video. What about this electronic configuration, this special notation? What does it tell us? All right. So we can see here. Now, this is the notation that we're dealing with. Now, and these are the number of notations, 1, 2, 3. All right. So we can see the first notation. What are exactly these notations? So these number one means the first shell. Number 2 means the second shell. And number 3 means the third shell. All right. Now you can see here, when we are writing number 1, corresponding to it, we are writing number 2. This means the first shell can hold up to 2 electrons. Is it easy? Yeah. So let make it more easier. I'll just explain the second shell also. So second shell, you can see here we are writing number 2. This is the second notation, which represents the second shell, and it can hold 8 electrons. All right. Now, if we move on to this last notation, the third notation, you can see in a chlorine atom, it can hold 7 electrons. I told you that it can hold up to 8 electrons, but it can, in this scenario, we are seeing that it is holding 7 electrons. This is because we have already filled 10 electrons, because if you see chlorine atom on the periodic table, you will notice that it has 17 electrons. All right. So in the first shell 2, in the second shell 8, 2 plus 8, 10. All right. In the third shell, it can hold then 7 electrons to complete its electrons. All right. Now let me just show you some statements, some important statements. Information deduced from the notation. So what we can deduce from this notations and from the period number, the group number, something we will be deducing. So you can see the period, the red numbers at the bottom show the number of notations, which is 3. Okay, so we have 3 notations. And if you see here, one second, yeah. So in this total, we have 3 notations. This means we have 3 periods, 3 shells. It's in period 3. If it was having 4 notations, this means it will be having 4 periods, 4 shells. If it's in 5th period, it will be having 5 notations and 5 shells. It goes on. Now, okay, showing that a chlorine atom has 3 shells of electrons. So we already discussed that. Now, what information does it gives about the group? Now, the group, it says that the last notation, it represents the last notation. The green box basically highlights the last notation, which is 7, showing that the chlorine atom has 7 outer electrons. I'll just discuss that. One second. Yeah. So this is the last notation. This means this is the last notation. It has 7 electrons in its outermost shell. And what we can also deduce that it is in the 7th group. Why? Because chlorine is in 7th group. It's in period 3, group 7. And it has 7 electrons in its outer shell. If we know the information about the number of electrons in the outer shell, we can also deduce the information about which group it's present in. So I hope you were able to get some of the concepts, and I hope you were able to catch up with most of the concepts. In the next video, as I promised, you will be discussing the noble gases, their electronic configuration, and all the periods from 1 to 20, how all the elements from 1 to 20, what is the electronic configuration, the special notation, everything we'll be going to discussing. Till then, take care, subscribe to the channel, hit the like button, comment down below, so as per your suggestions, we can upload our upcoming videos. That's it. Cheers.